Hello my dear children, welcome to the mathematics class. Today we are going to discuss permutations and combinations. In this chapter we are going to discuss the concepts of exercise 7.3. In the previous exercise we have discussed the concepts of exercise 7.2. In that exercise we have discussed the factorial n. I hope you have learnt well, and we have discussed the permutations, definition of permutations of n objects by taking or objects taking at a time, where all the objects are different objects. I hope you have learnt well. I hope you understood well the concepts. Okay, my children? Right. Now come to this exercise. Concepts of this exercise 7.3. Are you ready to listen the class? Right. See the first point. Derivation of formula for NPR. That is equal to NPR is equal to n factorial by n minus r factorial, where 0 less than or equal to r less than or equal to n. Okay, but so this is the formula for NPR, n factorial by n minus r factorial. Let us prove, let us derive this formula. Okay, my children. We know that the number of permutations of n different things taken or objects or things. Okay, my children, there are n different objects are there. From the n different objects we are taking or objects at a time. Is NPR is equal to n into n minus 1 into n minus 2 into and so on, n minus r plus 1, where 0 less than or equal to n. By principle of multiplication we have found this one. Do you remember this formula, my dear children? In the previous exercise we have discussed this point. Okay, my dear children. Now we write this formula in terms of factorial notation. Okay, my dear children. Right. Here in this number is multiply and divide by. That is multiply and divide. Multiplying the numerator and denominator by n minus r minus 1, n minus r minus 2, and so on. 5 into 4 into 3 into 2 into 1. Here we are multiplying this number. Here denominator is 1. So we are multiplying the numerator and the denominator by this number. Okay, my children. This implies NPR is equal to n into n minus 1 into n minus 2 into n minus 3 into and so on, n minus r plus 1 into, we have to multiply this number, n minus r minus 1, n minus r minus 2, and so on. 5 into 4 into 3 into 2 into 1 whole divided by n minus r into n minus r minus 1, n minus r minus 2, n minus r minus 3, and so on. 5 into 4 into 3 into 2 into 1. Okay, my children, understood this step. Here we are multiplying the numerator. Here denominator is 1. Yes or no, my children? So we are multiplying the numerator and denominator by n minus r into n minus r minus 1 into n minus r minus 2 into and so on. 5 into 4 into 3 into 2 into 1. Okay, my children, understood this step? Right. If you observe the numerator now, here this is nothing but the product of the first n natural numbers. See here in the reverse order, I told you, in the reverse order we write in general n factorial is equal to n into n minus 1 into n minus 2 into n minus 3 into and so on. 5 into 4 into 3 into 2 into 1. Okay, my children, so numerator is nothing but n factorial. Here the starting number is n minus r. We wrote these numbers in the descending order till the number 1. We wrote all the natural numbers starting from n minus r minus 1. Understood this point, my children? So this is nothing but n minus r factorial. So this notation NPR is equal to n factorial by n minus r factorial. This form is convenient to us more than this. This is more convenient than this definition. Okay, my children. If you find the value here and here, you get the same value. Okay, my children, understood? For example, if you want to find 10p3, 10 factorial by 10 minus 3 factorial. Example. Understood this point, my children? In this formula, I substituted n is equal to 10 and r is equal to 3. What do you get here? 10 factorial by 7 factorial. Okay, my children. How do you write this one? 10 into 9 into 8 into 7 factorial by 7 factorial. What do you get? 720. This is nothing but the value of 10p3. Understood this point, my dear children? Is it clear? Right. Now come to the next point. The number of permutations of n different objects taken or objects at a time when repetition is allowed is equal to n to the power of r. Okay, my dear children? Here n different objects are there. Out of these n different objects, we have to take only r objects. How many permutations, how many arrangements can be done? N to the power of r, because repetition of the objects is allowed. You know, we take n blanks, r blanks. Here, how many letters to be taken? R. So we take r blanks. First blank can be filled by n different ways. Second blank also n. Third blank also n, because repetition is allowed. Understood this point, my children? So n into n into n into r times. So we can write n to the power of r. Okay, my children? Understood this derivation of this formula? Right. You know, see here, we take r blanks. R blanks. First blank can be filled by any one of n different objects. Second blank also can be filled by n different objects. Third blank n different, because repetition of the objects is allowed. So we can use the same objects here. So like this, n into product n to the power of r blanks. Understood this point, my children? Right. Now come to the third point. The number of permutations of n objects where p objects are of the same kind and the rest are all different is equal to n factorial by p factorial. This is a special case. See here, my children. Some p objects are same kind. They are alike. They are alike. Same kind of objects are there. Out of n objects, p objects are identical. Identical. They are of same kind. Understood this point, my children? Then, in how many ways that letters can be arranged themselves and factorial by p factorial. to understand this point well, let us take an example. Find the number of permutations of the letters of the word root. You have to write all possible ways of arranging these letters. How many? What are the letters of the word? Letters of the word. Letters of the word are O, O, T. These are the letters of the word. Yes or no, my children? How many letters are there? 4 letters. Total 4 letters. Yes or no, my children? Total number of letters. N is equal to 4. So n objects. Total n objects. Total n letters are there. Out of these n 4 letters, see here O. These 2 letters are identical. These 2 letters of the same kind. Yes or no, my children? Here two O's are of the same kind. They are alike. They are said to be alike or identical. The 2 letters are identical. They are alike. They are of the same kind. How many letters are there? 2 letters are identical. We can say 2 letters are alike or 2 letters are of the same kind. Then number of permutations. Number of permutations of the letters of the word root is equal to n factorial by, that is n factorial by p factorial. So 4 factorial by how many letters are identical? 2 objects are identical. Understood this point, my children? Here identical objects are there. Identical objects are there. Some objects are alike. Some objects are of the same kind. In this case, to find the number of permutations, we follow this method. Okay, my children? In the previous exercise, we found number of permutations of n different objects. All objects are different objects. All objects are distinct. Okay, my children? Understood? Right. So 4 into 3 into 2 factorial by 2 factorial. So totally we get 12 arrangements, 12 permutations we get. If we arrange these letters among themselves, how many arrangements, how many permutations we get? 12 permutations, 12 arrangements. Understood, my dear children? Right. Now come to the next point, 4th point. This is a little bit extension of the point 3. Okay, my dear children? The number of permutations of n different objects, and n objects are there. The number of permutations of n objects, where p1 objects are of one kind, p2 objects are of second kind, and so on. pk are of kth kind, and the rest, if any, are different kind, is n factorial by p1 factorial into p2 factorial into p3 factorial, and so on into pk factorial. Okay, my children? In the number of objects, n objects, p1 objects are alike. They are of same kind. Okay, my children? They are same kind, identical. p2 objects are identical objects. p2 objects are identical objects. They are alike. Similarly, pk objects are and so on. Pk objects are alike, they are of the same kind, and the rest of the objects, if there any, they are different kinds. Then the number of permutations equal to n factorial by p1 factorial into p2 factorial into p3 factorial into and so on pk factorial. Okay, my children, to understand this point well, let us take an example. Find the number of permutations of the letters of the word mathematics. Okay, my children, how many permutations can be made? How many words can be written by using the letters of this word? Okay, my children, now come to the solution. Letters of the word. The letters of the word mathematics are M, A, T, H, E, M, A, T, I, C, S. Yes or no, my children? Total, these are the letters of the word. M, A, T, H, E, M, A, T, I, C, S. Out of these letters, how many objects are there? Total number of objects. Total number of objects. Total, how many letters are there in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 letters are there in the given word. Understood this point, my children? Right. So, in this word, 11 letters are there. Out of these 11 letters, see there, 2 A's are there, 2 M's are there, 2 T's are there. Yes or no, my children? Here, these two letters are identical. These two letters A's are same kind. They are of the same kind. They are identical. They are said to be alike. These two objects are alike. Similarly, number of M's. How many M's are there? 2 M's are there. Yes or no, my children? Next. How many T's are there? Number of T's. These are also 2 T's are there. These two letters are identical. These two letters of the same kind. These two letters, these two objects are of the same kind. These are said to be alike. They are of the same kind. They are identical objects. Understood this point, my children? These here 2 A's are identical, 2 M's are identical objects, 2 T's are identical objects. Are there any identical objects are there, my children, in these letters? No. Here the rest of the letters, how many, what are the rest of the letters? H. Only one H is there, only one E. Next, H, E. Next, C. Next, number of I's. Number of S. Total, let us count the total number of letters. 4, 2 plus 2, 4, 4 plus 2, 6, 7, 8, 9, 10, 11. Total 11 letters are there. Out of these letters, some objects are alike, some objects are of same kind, some objects are identical objects. Okay, my children. So in this case, the total number of permutations is equal to 11 factorial by, therefore, number of number of permutations is equal to 11 factorial by 11 factorial by 2 factorial into 2 factorial into 2 factorial. Understood this point, my children? Here no need to write 1 factorial, 1 factorial, 1 factorial. More than 1. We write here as a factorial in the denominator. Here 2 factorial into 2 factorial into 2 factorial. Understood this point, my children? Understood this step. After that, simplify this number. Can you simplify this number, my children? Can you find the value of this number? Right. I am leaving that part to you. Calculate that number. Okay, my children? Understood? Right. Concepts of exercise 7.3 were completed. Okay, my children? In this exercise, we have derived NPR in terms of factorial. Okay, my children? NPR is equal to n factorial by n minus r factorial. And second point, the number of permutations of n objects, taking r objects at a time when the repetition is allowed, that is n to the power of r. Okay, my children. Next, when the objects are alike, out of n objects, p objects are alike and the rest of the objects are of different kinds, then the number of permutations is equal to n factorial by p factorial. And fourth point, out of n objects, we have to take all the objects. Okay, my children, we have to take all the objects in the arrangement. So in this n objects, p1 objects are of same kind, p2 objects are of second kind, p3 objects are of third kind, and so on. pk objects are of kth kind, and the rest of the objects are different kind. In that case, the number of permutations is equal to n factorial by p1 factorial into p2 factorial into p3 factorial into and so on pk factorial. Okay, my children, these are the 4 points we have discussed in this exercise as a part of concepts. Okay, my children, we use these concepts in solving the problems in the exercise 7.3. Okay, my children, right. See the page number 148 in the textbook. See the question number 1. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Understood this question, my children? What are the objects to be used 1 to 9? Okay, my children. What are the digits to be used? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 objects are there. 1 to 9 digits. We have to use 1 to 9 digits. These are the digits to be used to write a 3-digit number. Okay, my children. So, number of 3-digit numbers, we can use fundamental principle of multiplication here. Okay, my children. Right. So, number of 3-digit numbers. Number of 3-digit numbers by using the digits 1 to 9. The number of 3-digit numbers by using the digits 1 to 9 is equal to number of ways of filling the three blanks given below given below by these 9 objects. Okay, my children. The number of 3-digit numbers is equal to the number of ways of filling the 3 blanks, because we want a 3-digit number. Okay, my children. So 3 blanks given below by these 9 objects. Okay, my children. So this one, this is our first, second and third. 3 operations are involved in writing a 3-digit number: 100 place, tens place and units place. Filling the hundreds place is one operation. Filling the tens place is a second operation. Filling the third place by the digits is a third operation. Okay, my children. If no digit is repeated, no digit is repeated. Repetition is not allowed. Okay, my children. So, in how many ways this first blank can be filled by these 9 objects? 9 possibilities. Yes or no, my children? So, this first operation can be done in 9 ways. Okay, my children. The second blank, in how many ways? Already one blank is filled. So, how many objects will be there in our hand? Only 8 objects will be left in our hand. So, the tens place can be filled by the remaining 8 objects in 8 ways. Understood this blank, my children? 8 into third operation. How many objects will be there in our hand after filling these 2 blanks? Only 7 objects there in our hand. Only 7 objects will be left. So this third blank can be filled by any one of the 7 objects. So by the fundamental principle of multiplication, what you get? 9 into 8 into 7. Multiply these 3 numbers. So 504 3-digit numbers can be written. 304 3-digit numbers can be formed by using these 9 objects, 9 digits without repetition. Understood, my children? Otherwise, you can use n is equal to here, n is equal to 9 and r is equal to 3. So NPR. So 9P3, 9 into 8 into 7. You can use this method also, because all the objects are distinct. All the objects are distinct. In this case, we can use this formula. Okay, my children, understood this point? Right. Now come to the next question, question number 2. How many 4-digit numbers are there with no digit is repeated? Understood this question, my dear children? We have to write number of 4-digit numbers when the repetition of the digit is not allowed. Okay, my dear children? Understood this question? Right. Come to the solution. Digits to be used to write a 4-digit number. Which digits are used here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes or no, my children? If you want to write a 4-digit number, we use these digits only. In the question, it is not given, but we use only these digits or not? Yes, we use these digits. Okay, my children? Right. So, number of 4-digit numbers. Number of 4-digit number of 4-digit numbers by using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When the repetition of the digits not allowed is equal to number of 4-digit numbers by using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When the repetition of the digits is not allowed is equal to number of ways of filling the 4 blanks in that number. How many digits should be there? 4 digits. So we are taking 4 blanks. Okay, my children. So number of ways of filling the 4 blanks by using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When the repetition is when or with no repetition is allowed. With no digit is repeated. Okay, my children. So here we are taking 4 blanks. This is thousands place, this is hundreds place, this is tens place, and this is ones place. 4-digit number means these 4 places are there: ones place, tens place, hundreds place, and thousands place. Yes or no, my children? Now let us fill these blanks by these digits. Okay, my children. Now first blank, number of ways of filling thousands place blank. In how many ways we can fill this blank? Can we write here 0? If you write here 0, is it said to be a 4-digit number? No. You have to think this logic, my dear children. You have to think this logic. If you write 0 in this place, we can't say this is a 4-digit number. It is said to be a 3-digit number. So this thousands place can be filled by these 9 digits only, either 1, either 2, by either 3, or by either 4 or 5, 6, 7, 8 or 9. So thousands place can be filled by any one of these 9 digits except 0. We exclude 0. Understood this point, my children? Next, number of ways. So here we use 9 digits. Number of ways of filling hundreds place. Now come to this point. After filling this first blank, how many digits will be left in our hand? 9 digits. Yes or no, my children? Total 10 digits are there. Out of 10 digits, we have used 1 digit in this blank. Except 0, we have used this blank. So how many digits will be rest there? Yes, 9 digits will be there. So this hundreds place can be filled by the remaining 9 digits. Yes or no, my children? Right. Now number of ways of filling tens place. Then how many digits will be there in our hand after filling these 2 blanks? After filling these 2 blanks, out of 10 digits we have filled by 2 digits. Yes or no? How many digits will be there in our hand? Only 8 digits will be there in our hand. So this tens place can be filled by any one of 8 digits. Yes or no, my children? Right. Next, tens ones place. Number of ways of filling ones place. After filling these 3 blanks, out of 10 objects we have filled these 3 blanks. 3 objects were filled. How many objects will be left in our hand? 7 objects. Yes or no, my children? Yes. So these are the ways of filling first thousands place, hundreds place, tens place and ones place. Therefore, by fundamental principle of counting, fundamental principle of counting, or you can write by the fundamental principle of multiplication, fundamental principle of multiplication, we can write 9 into 9 into 9 into 8 into 7. Okay, my children, 9 9s are 81, 7 8s are 56, 6 8 5 6 4136, 4000 5 9 81 616 6 48 13 4 5 36 4536 4 digit numbers can be formed by using these digits. Understood, my dear children? Right. Now come to the next question, that is third question in the exercise. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? Understood this question, my dear children? We have to find the number of 3-digit even numbers by using the digits 1, 2, 3, 4, 6, 7 with no digit is repeated. Understood this point, my dear children? Right. Come to the solution part. Digits to be used to write a 3-digit number, 3-digit even number. What are the digits to be used here? 1, 2, 3, 4, 6, 7. They have given itself in the question itself. Okay, my children. Out of these 6 digits, what are the even digits? 2, 4, 6. We are focusing on the even digits because we are writing a 3-digit even number. That is why we are identifying the even digits. What is meant by even number? If the units place, if in the units place there is a even digit is there, even digit is there in the number in the units place, then the number is said to be even number. Yes or no, my children? A number is even if the units place is even. Yes or no, my children? Yes. So by using this definition, you have to recollect the previous knowledge. What is meant by even number? What is the definition of an even number? A number is said to be even number if its units place is even. Okay, my children, that is why we concentrated on even digits. Okay, my children, right. Now come to this step. Number of 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated. If no digit is repeated is equal to, I wrote the same question. What is the sentence is given in the question? I wrote the same sentence here. Is equal to number of ways of filling filling the 3 blanks. Why should we take 3 blanks? Because we have to write a 3-digit number. That is why we are taking a 3 blanks. So number of ways of filling the 3 blanks given below by using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated. So that is equal to, so I have taken 3 blanks. Ones place, this is ones place, this is a tens place, this is a hundreds place. So first we concentrate, we focus on units place because we have to write even numbers. So first we have to focus on units place. So the first units place or ones place can be filled by these 3 digits. Yes or no, my children? If you fill by these numbers, either 1 by 3 or by 7, is it number said to be a even number? Not at all. That is why first we fill this units place by these 3 even digits. Yes or no, my children? So number of ways of filling ones place. Three ways. By any one of these 3 digits we can fill. Yes or no, my children? Either 2 or either by 4 or by 6 we can write here. Okay, my children, after filling, here also 3 operations are there. 3 events are involved. In writing a 3-digit number, 3 operations are involved. So first operation is over. First event is performed. Okay, my dear children, first job is performed. Now we go to the second operation, second event, second job. You are filling the tens place blank. Number of ways of filling tens place blank. In how many ways we can fill this second tens place blank? Out of these 6 digits we have used 1 digit. Yes or no, my children? We have used only 1 digit. Then how many digits will be left in our hand? 5 digits. Yes or no, my children? Yes. So this tens place digit, this tens place blank can be filled by the remaining 5 digits. Understood this point, my children? Right. Next, number of ways of filling hundreds place. Then how many digits will be left in our hand? 2 digits were used. 2 digits were used to fill these 2 blanks. How many digits will be left in our hand? Out of these 6 digits, we have used 2 digits. Understood this point, my children? How many digits will be left in our hand? 4 digits. Yes or no, my children? So 4 digits. So this is the first operation is done in 3 ways. Second operation is done in 5 ways, and third operation is done in 4 ways. So number of ways. Therefore, by the fundamental principle of counting, number of ways, total number of ways is equal to 3 into 5 into 4. Okay, my children, don't be confused here, my children. Total is not to add these 3 numbers. We are using the fundamental principle of multiplication. We are using that principle here, not we are adding. So 3 into 5, 15, 15 into 4, 60. So totally 60 even digits can be formed by using these 6 digits. 3-digit even numbers can be 360. 3-digit even numbers can be written by using the digits 1, 2, 3, 4, 6 and 7. Understood, my dear children? Right. By using this knowledge, can you do the question number 4, my dear children? Please try the question number 4 yourself. Fourth question is also same as that of question number 3. Same like this one. Okay, my dear children. Please read the question carefully and do the question number 4 yourself. Try it. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Right.